you have any question about the quiz?
I'm one on B31.
This one?
Yeah.
Okay.
I don't know if I'm getting it right, but I thought, shouldn't the KSP, where you have like the parentheses stuff, be 2 parentheses to the 3rd power?
I think what you say is right. So this will be like this. So KSP will be if S amount dissolve, this will be S, this will be 2S. So KSP is equal to CA2 plus F minus square. We plug in that guy over here, S, and 2S square. That will make it 4S.
Okay.
Anything else? If not, let's move on. So this is continuation of what we did last time. We want to find the molar solubility. Let's use S for solubility here. And PB red bromide will dissociate as Z2 plus 2 bromide. So if S amount dissolve, we're going to have S here, S here. It's just same situation as what you asked just now, right? Same situation. So soluble product is KSP is again PB2 plus bromide square. Therefore, S here, 2S there raised to second power, 4S cubed. Exact same situation. The difference is instead of asking KSP, they are asking for molar solubility. So that's opposite situation. Now we are given soluble product right there 4.6, and there 6, and then we find out S value, solubility. Okay, so divide by 4 both sides. And then take cube root both sides. There's 2 sig big, just dividing 2 sig big. And the solubility has unit as concentration. That much you need in the solution. Why don't you try question B? Why don't you try this?
same number or different number? So silver sulfide dissociate like 12 silver plus 1 sulfide, right? So KSP value will be silver concentration raised to second power and sulfide. And the KSP is given right there, this number. And also given is concentration of sulfide ion. So that goes here. Question is asking what will be concentration of silver. So you divide that guy by 0.05, take square root. That's our answer. Okay? If you punch into calculator, you're gonna have a number. There's 2 sig feet. There will be 2 sig feet here.
Why do we raise the,
Mhm.
why do we raise the one ion to the, why do we square the one ion?
Why do we square here?
Yeah,
When reaction happen, if we have 2 in front of ion or molecular reactant, that will relate to second power. That's the principle. But are you asking the principle or are you asking the reasoning behind?
I guess the reason.
Reasoning behind.
Oh, is it just cause we're, it's just, okay, I guess in my head I wanted to just say it was just multiplied by 2, not twice itself.
Okay. So for the reasoning,
Cause the ratio is like 1 to 2 moles, right?
yes.
1 mole to 2 mole,
Mhm.
so.
That ratio is reflected here.
Mhm.
So 1 to 2 ratio, that is equals here. That's important.
Right,
There's another thing that when you have 2, it also enter as an exponent. So this one is just contribute twice.
just so I get it.
One as ratio, the other one as power.
Okay.
Now if that is 3, this will be 3s, and then Q.
Does that have to do with the, like the pH scale, because everything's a log? So that we add, if we're adding, like,
Yeah,
Again, why would
so
I
you're asking
do-
why that's related to power,
Yeah.
right? Let's say, let's give you example. How often do you have traffic accident? Well, I'm not asking number. The traffic accident will be proportional to number of car on the street, right? If you have more car, there will be that much more accident possible, right? At the same time, even if you have, let's say, traffic accident as a rate, accident rate, then it will proportional to number of car. At the same time, for the same number of people on the street. Because to accident happen, you should have car and some people, right? So there will be number of car times number of people. What about traffic accident between car? If you have more car, the traffic accident between car is car times car. So you multiply between car and car, so it will be squared, right? So here, when reaction happen, if that is, let's say this is one of the car, this is another car. Two reactions happen, they should collide. So that will be concentration PB times concentration BR. Now instead of this, reaction is between bromine and bromine. It will still this concentration times this concentration which is related to second power. So in reaction you may write this one as those 2BR. So coefficient actually turn into exponent. In this case we have one of the PB, another BR, and the BR, something like this. So it will be proportional to each one of them, but this guy raised to second power, this guy just multiplied here.
I guess I get it, so if it's 3, it's to the 3rd power.
Yeah, so whenever you have 2
Twice
here,
with the 2 and the exponent.
uh,
I don't know, I'm having trouble wrapping my head around it. It seems like we're doing it twice with the with a 2 or a 3, whatever we put in front of it, and then also adding the exponent.
Yes. The reason is that so if you consider just accident between car, okay, accident between car.
How about an
So let's say we have like 1,000 cars in Lansing, and it's not true. And then Chicago, we have 2,000 cars. Is the traffic accident will be just twice? Well, in terms of concentration, you have to double. If this is S amount, you have to double. But at the same time, traffic accidents happen between cars. Because of that, you multiply to this, to again, that concentration. So that's why it double in terms of concentration. Also, it should be squared. So you have more, and then also interaction between those more stuff. So you just concentration double, and then raised to power as well.
Think of it as two separate things, like the 2 is for your S's, it's telling you how many S's you have, right? That's what you're using the coefficient for. But in terms of your KSP, your 2 is telling you your exponent ratio. So when you're thinking of it as S's, anytime you see a coefficient, if there is a coefficient, so in this case we have 2, that's telling you how many S's you have for that, so 2S would be your bromine right there. And then when you're doing the you have parentheses, and you have the KSP, your coefficient telling you your exponent number. So it's kind of like 2 separate things.
Is it basically the same reason though why
Mhm.
the pH scale is like exponential like that too? Where, you know, each level up is like 100 or 1,000 times more than 1. Is that where that kind of comes from? From the,
Maybe, but not directly. But pH scale is basically when you count, like 10, 100.
yeah, I don't
Thousand.
want to get like too
Yeah.
basic with it, but
Yeah,
just
just make it-
conceptually, I'm
yeah.
just trying to kind of visualize it.
Yeah.
I guess
Are you good?
I don't know. I mean, I can just do it. I don't need
Okay.
perfect.
Yeah. So I can explain further. You can talk
Yeah.
in person, but for principle. So if you have any number in front of a molecule, that is double concentration or triple, and also raised to that power.
Okay.
But I can explain further. Okay. Any other question? Okay. So that solubility, when you put some salt, like AgCl in the solid phase in the solvent, this guy dissociate and dissolve like this. Now there are certain factor will either increase or decrease this solubility. It will be decreased if you have common ion. For example, this is dissociated as silver and chloride, so that will be equilibrium between solid phase and aqueous phase. Because it's equilibrium, if we put certain common ion, extra chloride here, increase this guy, then equilibrium will shift to left. That's a common ion effect. That means this will be less soluble. Okay. On the other hand, let's say I have AgCN dissolved in the same situation. This guy is CN minus cyanide. This guy is conjugate base of weak acid. Therefore, in this case, if you add acid to here, now that's not carbon ion, but this guy will react with this, so H plus will react with cyanide,
make HCM. So if this guy remove some of the product, then equilibrium will shift to the right. Okay? So that will increase solubility. So common ion effect again, calcium fluoride will dissociate as calcium 2 plus and 2 of fluoride ion. If you add fluoride, that's common ion. So you can shift to the left. So solubility will decrease. If you look at this graph, depending on how much common ion you put into this solution, you add more, solubility decrease. In the pure water, solubility is this much, 10 to the negative force, but if you add more and more, that decrease. If you understand meaning of graph, that's enough. So, in which salt will make solubility decrease then? So you have AgI in solution, silver iodine solution, which will make solubility decrease.
AI,
Which one?
C.
C? Yeah, if you put C, this guy provide the common ion of this guy, so it will definitely decrease solubility.
Would E be the same?
E would be same.
Okay.
This guy provide silver as common ion here, that will also decrease solubility. So answer will be C and E. Okay. Then what about second one? This is similar question. This time you have silver chloride. In what solution this is dissolved most? When this will dissolve
Pure water.
Pure water.
pure water, because it doesn't have any common ion. What about I'm gonna make up D, 0.2 molar Na pure solution. And answer is what? Which one is answer? Still A? What do you think? A and D. Why? It has something, but that doesn't provide any common ion. So practically, solubility will be almost equal. Unless you see other reason, then it should be. Okay? As a practice, why you don't use this? Find the solubility in that solution.
So why don't I explain? So you have red bromide that will dissociate as 2-bromide and red. Well, in this case, we have common ion, so which means bromide will be provided by through sodium bromide. So we already have this guy even before dissociation of that guy. So initially we have that, and then some of them will dissociate. So if you dissociate S amount, here you have S amount. This will be twice of S, 2S, and then add to this guy. So KS expression, just plug the number. Red we have S. This guy is 0.10 plus S. That's the second power. Like acid base case, this K value is equilibrium constant and that's very small. If it's very small, only a little bit dissociation. So S will be very small number. Therefore, compared to 0.10, 2S can be ignored. So right here we assume 0.10 is greater than 2S. This means this is a lot greater than that guy. With the assumption, we have a 0.10 square, and you got this number. Now, because this is S, let's put this one back to here if that was true. Because S is that, 2S will be what? 0.0009, right? So you can see this guy is less than 1%. Because 1% would be 0.001. This is even smaller than that. Okay? Anytime you have a less than 1%, you can ignore it. Okay? So that was solid change when we have common ion. Solid also change when you change pH. This is example. Magnesium oxide, hydroxide. Magnesium hydroxide is a base, but that's not a strong base. Strong base, so magnesium group 2, and group 2 there is only 3 strong base, Cas bar. So magnesium is not one of them. It's a weak base. That's why you have double arrow. It will dissociate like that. But once it dissociates, it will be a little bit basic. But that is not completely soluble, so that's why you have a double arrow. To this equilibrium, if we add acid, then this acid will react with hydroxide, forming water. So adding H plus to this equilibrium will make it equilibrium shift that direction, right? So it increase solubility. So you can explain that as these two reactions. That is a regular dissociation, and if we add the acid, there will be neutralization. So together, if we add, the overall reaction will be this one cancel. So magnesium hydroxide plus hydrogen ion, that is turn into magnesium and water. When you add two reactions, this will now single arrow, not double arrow. So anytime when you use a strong stuff with weak stuff, the strong one always win. So that's why it's a single arrow. Okay? what will happen? You have calcium carbonate. This guy is very tiny, a little bit soluble. It's not much soluble. If you're lowering pH, if low pH, would that increase solubility or decrease solubility, or it has no effect? Lower? So calcium carbonate will dissociate just like this. And it dissolves a little bit, tiny bit. Okay? So if you lower pH means increase hydrogen ion concentration, which means you are adding acid. So you are adding acid. If you add acid to this guy do not react with calcium, but it will react with carbonate, and then react. That's a single arrow. Close. Strong acid with weak base. With a single arrow, and become bicarbonate. Okay. So adding hydrogen ion will remove this product, so equilibrium shift right, which means solubility will increase. So what if you see this on the exam? How do you explain? Well, you have to explain basically just like this. Okay? So you can write without any help, you have this equilibrium situation, but because you are adding action. How do you know you are adding action? Because you are lowering pH. Lowering pH means you are adding action. So those incoming acids will react or not, but you have to decide whether this acid will react any of the product. So you see, oh, this guy is conjugate base, which means they will react, and they will produce bicarbonate. You can add a little more, expansion in the word, but you have to include this equation. Okay? And then because of this reason, solubility will increase. What about this then?
Real quick, can you
Yeah,
explain?
sure.
I understand how how the H plus reacts with the
Carbonate.
CO3. Yeah, I understand that. Why is it shifting the equilibrium to the right?
Okay. So without adding acid, this is what we have as equilibrium. But once you add hydrogen to this equilibrium, secondary reaction shows they will react together and turn into this, which means this guy disappears.
Oh, okay. Thank you.
Yeah. What about second one? Increase. Different answer? Increase. So everybody say increase? No. It doesn't. Okay. Calcium chloride will completely dissociate. Okay. Now we're gonna add acid. Then now we have to decide the acid reacted with what? Cl minus and turn into HCl. HCl is known as strong acid, right? They do not come back. Once they dissociate, they do not come back. So if you add those two guys, they do not react. So basically, this one, no reaction. Nothing happens. So you add acid, do not change anything about product. So don't change. By the way, calcium chloride is completely soluble. I think it might be completely soluble anyway. because if you see the solubility rule, anytime when you have group 7 anion chloride, there's only few exceptions that doesn't complete soluble. Anybody has solubility rule? Okay, that's good. Yeah. So it's soluble. When you have chloride or bromide as anion, there's only few exceptions that's not soluble. Other than that, it is almost soluble. Okay. So, but doesn't matter if there's a single arrow, double arrow. This does not affect solubility. Okay. Right. Okay. So, which one is more soluble than in pure water? So you have put this guy in the acidic solution and the pure water. So when you add actually, which one will dissolve better than pure water? In pure water. So basically, you are asking, this is pure water, this is acidic water, and you are putting this guy in two different beakers, and you try to compare which compound dissolve more in acidic water. B. B is right. Why? Yeah. This guy will produce cyanide, and the cyanide actually will react if you add acid. This guy will react, become a HCN. So adding acid will actually remove product. So you can shift that. But the thing is, this question is copper cyanide actually very soluble. So if it's already completely soluble, that wouldn't help. Okay? But we're gonna say it's very soluble, but maybe not completely. So in that case, adding acid will help. Okay? But if some compound is already completely soluble, there's not much to help anymore, right? But we're gonna assume if you read the solubility rule, this is almost soluble, but we are not saying completely soluble, okay? Yeah, so it is still help. So I'm gonna write, to avoid the confusion, I'm gonna use double arrow. Okay? But is there any other answer? Huh? C. C? Yeah, C is also another answer. Why? Because when this guy dissolves, actually this will produce phosphate. Wait. Phosphate ion. Phosphate is conjugate base of acid. So if you add hydrogen, this will react. Similar. In that sense, I'm going to double arrow here as well. Yeah. Okay,
So is it safe to assume when you're solving these types of questions that the top equation will always have the double arrow and the bottom equation will always have the single?
yes.
Okay.
Short answer is yes.
Okay.
Because first one is just we are basically talking about solubility. Solubility. When you say solubility product, we are talking about basically equilibrium constant. Because it's equilibrium constant, you are using double arrow. Whether that's like a little bit soluble or a lot of soluble, still unless that's complete, dissolution, that you're gonna still use double arrow. Yeah, always use double arrow. But second one is single arrow because you are adding strong acid. So that's why I just change this one as this. even if that's very pretty much soluble, I'm not going to say it'll be 100% soluble. So I'm going to still use double arrow. Okay. Good question.
Thanks. That was helpful, thank you.
Now, when we talk about solid product, we have salt dissociate into ion. This slide is saying opposite. If you have certain ion, they will make precipitate. Okay? So you have two solution, silver solution and chloride solution mixed together. Then you'll see, so if you pour silver solution and chloride solution together, you'll see precipitate form in the bottom of the beaker. That's what precipitation is. Now we're gonna have to decide when you mix two solutions whether that will form precipitate or not. We approach it quantitatively. You compare KSP against, no, actually Q against KSP. Q is what we call reaction quotient. You have learned this one at General Chemistry 1. So reaction quotient is same as equivalent constant in terms of the formula. For example, when you have reaction and equivalent constant would be product over reactant. The reaction quotient Q is exactly same. Only difference is K value is defined for the equilibrium concentration only. Okay? We do not write equilibrium concentration, just we do not put EQ here because it's already assumed. So even if you do not have anything here, constant is at equilibrium. But sometimes constant may be measured while it's not at equilibrium. So then we should actually say that as Q rather than K. Okay? And then we compare those two guys and then determine if precipitate or not. Okay? Let's see example. Let's say equilibrium constant between these guys is something like 10. Okay? And then I have, in some situation, let's say, just this concentration. Then if I plug in that, 1, 1, 1, 1, become 1. Right? So Q is less than K. That means if I have this situation, this is not at equilibrium, so this should shift until that achieve equilibrium. So should that reaction go to forward or backward? For this, because equilibrium constant should be 10, which means we cannot have equal amount of both reactant product, we have to have more product. So reaction should go forward, right? Same way, KSP is for AgCl, for silver chloride, that's KSP. So you can define similarly Q as Ag plus Cl minus. So let's make them again. This is 10, and I have 1 molar concentration of each. Then this will be Q will be 1. So then reaction should go forward or backward? So then the reaction should go forward or backward. If KSP is 10, and I have right now 1 molar concentration of each.
forward.
forward. Yeah. So Q is less than K, then it should dissolve more. In opposite case, if this is 1, this is 10, then because Q is greater than K, reaction should go backward. So which means this guy will come together, make a precipitate. Okay? That's how you decide whether precipitation happen or not. It is only more actual problem. Well, answer is already here, but why don't we try magnesium nitrate? Magnesium nitrate will dissolve like this. So my KSP expression or Q expression, I will say Q is Mg 2 plus NO3 SK. No. I'm sorry, this will complete dissolution. They are asking, would this one, this precipitate will be formed or not? So I'm going to change this one to MgN. Okay. Concentration of magnesium is before mix anything, the concentration was this guy, but if you add two solutions together, concentration will change, right? So concentration of magnesium is together 0.01, 1 millimole. In total volume is we are adding those two solutions, so that will be 400 milliliters. So that's the concentration of magnesium. Concentration of fluoride is that times this 0.1, which means 25. 25 millimole inside of 400 milliliters. And then we have a scale there. So I'm going to have this number. And then compare this Q with the K value. KSP is 6.4 10 to minus 9. And if you compare those two numbers, this one is greater, right? Q is greater. Q is greater than KSP. So that means you have more of ion in the solution than equilibrium condition. solution, so they will come back together for precipitate. Okay. Does it make sense?
Where,
Mm-hmm.
I see where you got the 400 milliliters.
Mm-hmm.
Where did you get the 1.5 millimole and the 25 millimole?
So that's from magnesium. Magnesium is coming from this guy, and concentration is 0.01, and I have 150 milliliter.
Oh, so you multiplied them.
Multiply.
Okay.
Okay. So why don't you try? Why don't you try? This is what you actually get. Why don't you confirm yourself?
Why does that equation get a double arrow, but the other one got a single arrow?
This should have its double arrow. Thank you.
Thank you.
That. So copper hydroxide will dissolve like this. So I write Q instead of K, but same expression, right? And then we know the copper solution has this concentration right there. And we don't know this concentration is at equilibrium or not. We just about to see it. So put that number. And the pH is adjusted to 6.5. We know pH will be 7.5. And convert back to hydroxide concentration. Because that number is required in the hydroxide concentration, just plug in there. That's how we got Q value. Now we just say Q because we don't know this will be equal to K value or not. And then it turned out to be that is a greater number than K, which means you have too much product right now. So if you have too much ion, then they will come back, become solid, which means you're going to have precipitate. Okay? Sometimes, so far you have one metal ion and you are adding a certain anion, and to see they will precipitate or not. Some other case here, you may have two kind of metal ion, or example here zinc and copper coexist in a solution. Okay? And then when you add sulfide, when you have sulfide using hydrosulfuric, not hydrosulfuric, this is dihydrogen sulfide. When it dissolves in the water, that turn into hydrosulfuric acid, right? And then that's weak acid, and because it's weak acid, some of them will dissociate just like this. That guy actually, let's see. And then this guy also could further dissociate. Right? So that's the equilibrium between the two different reactions. You don't have to know this one yet, but I'm just writing it as reference. So that anion can react with either of cation. So copper 2 plus would react with S2 minus to form copper sulfide. Zinc plus also react with sulfide to form zinc sulfide. But if you look at Ks value, this one is smaller. Then which one is more soluble between copper sulfide and zinc sulfide? This number is greater, so zinc sulfide can be a little more soluble compared to this guy. Actually, neither of those guys is very soluble. It's not like they're almost insoluble, but still, if you compare between two, this guy is a little better than the other guy. This is more soluble. Okay? So if it's more soluble, when you just think opposite, it's easier to form precipitate, right? Because it's more, no. Because it's more soluble, it's less likely to form precipitate. Okay? So that's the principle of selective ion precipitation. So when you have two ion, you can put certain anion to form precipitate. Because the number is different, one guy will form precipitate first. So in this case, copper sulfide, because that's less soluble, which means this guy is more likely to form precipitate first. So you can separate zinc and copper. Okay? when you have mixed ion, you can separate them using precipitation. That's what we call selective ion precipitation. Let's do some practice. So this is this question is two part. When you have silver and red ion, and you're adding iodide. You can form either AgI, silver iodide, or red iodide. Okay. The question is, which one will fall first? Which one become a solid first? So to find out which one will precipitate first, you're gonna have to find out the KSP. Let's do this. So KSP for PBI is, that's a number, but expression will be PB I minus K. KSP of silver iodide, silver and iodine. And then we are given a concentration of each ion. For red, this will be 0.0050. For silver, we are given, that's the same, okay, same number, 0.0050. Is that right? Yeah, same number. So you can set up equation to solve I minus here. So you use this number that equal to that. So I minus concentration for PBI is 1.4 divided by this number inside square root. On the other hand, iodide concentration here for silver iodide is because that is equal to this this number divided by this. So if you do math, you do calculation, 8.3 divided by 0.005, 1.66 minus 14 relative. Here, inside of square root 1.4 8 divided by 0.005, 1.67 and minus 3. Can you confirm if I have the right number
Yeah.
for both? Okay. Then you'll see that iodide concentration is pretty different, right? So which means when you add iodide, which concentration will happen first between two? Small number, right? Because if you keep adding concentration increase like this, which means when you pour iodide this much, that's when already you are forming silver iodide. So that's a concentration not enough to form this precipitate yet. So that way, when you pour iodide, this will form first. Okay. Therefore, AgI precipitate first. Any question here? Okay. I'm gonna from today I'm gonna stay in the classroom about 25 more minutes every day. So if you have any question, just you can come. But I'm gonna stay here.